Hello everybody. Are you ready for my class today?
Hello, teacher.
Hello, teacher.
Hello, teacher.
Yes.
That's great. I hope all of you are energetic for my class today because today we are going to learn on new topic. Can you see my screen or my slide?
Yes,
Yes, miss.
teacher.
Yes,
Yes.
teacher.
Okay, good. But before that, I would like to show you a carbon. I have a green carbon, and all of us know that carbon has 6 protons, 6 neutrons, and 6 electrons. Do you agree?
Yes.
Not sure, teacher.
Not sure?
Yes, not sure.
All of you have to... Okay. All of you have to agree because we have learned this before, right? Carbon has 6 protons. Okay? But what if I have another carbon, which is the pink carbon and also the blue carbon? It has the same number of protons, but different number of neutrons. For the pink carbon, it has 8 neutrons, while the blue carbon, it has 5 neutrons. Do you think this can be happen? What do you think?
I think it can be happen.
It can be happen. What about the rest?
I never seen this situation before, so I'm not really sure.
Okay. Um, Actually, yes, it can be happen. Iliana answers correct. And this is what we call isotopes. Okay. So today we are going to learn about isotopes and its uses. Alright, before that, I would like to emphasize the lesson outcomes. At the end of this 35 minutes lessons, students are able to deduce the meaning of isotopes, calculate the relative atomic mass of isotope, justify the uses of isotopes in various fields. And for the educational emphasis, at least 3 students are able to deduce the meaning of isotopes, calculate the relative atomic mass of at least an isotope, and justify at least 3 uses of isotopes in various fields. Okay, now we are going to look at the first part, which is definition of isotopes. Okay, just now we have discussed a bit on isotopes, right?
Yes.
Yes. Okay, so can any one of you give the definition of isotope with your own words? Anyone would like to try? How about Naura? Naura, are you there? Okay.
Yes, miss. Can you hear me?
Yes, can.
Okay. From what I understand, isotope is the same number of proton but different number of electron of an element. Is it?
Yes, it's correct, but it is not really accurate. But never
Same
mind,
number.
it's a good try.
Okay.
Yes, same number.
The number of proton, different number of neutron.
Yes, correct. Alright,
Thank you,
that's
miss.
a good job, Nora. Okay, you're welcome. Okay, so this is the definition of isotopes based on your textbook. I would like to give Nora a confetti for her good try. Can you see the confetti? Yes? No? Class?
Yes, miss. Thank you.
Okay, alright. So isotopes are atoms of the same element with the same number of protons but different number of neutrons. Okay, for example, we have chlorine 35 and chlorine 37. Alright, now we look more deeper into the example. Okay, for chlorine 35, it has 17 proton, 18 neutron, and 17 electron. But before that, we have learned right. The alphabet here means the symbol of the element. How about the number 35 and 37? What does it refer to? Atikah Ibrahim, do you know? What does it refer to?
Yes. For chlorine, 35 refers to the sum of the number of protons and number of neutrons. For 37, it also refers to number of protons and number of neutrons.
Good, that's correct. Here, confetti for you. Okay, how about the 17? The number 17 here, what does it refers to? Can I have Fatini?
Yes, teacher.
Yes,
It's
what do you think?
number of protons.
Yes, correct. Another confetti for you. Okay, so how about we want to find the number of neutron? Does anyone know? We can't see, there is no indicator for neutron here, right? So how do you want to know the number of neutrons? Can I have Sabrina to
Yes,
answer
Miss.
my question? Yes.
To find neutron number, you need to minus 35 minus 17. Am I correct?
Yes, correct. Yes, correct. Here, confetti for you. And then, same goes to chlorine 37. 37 minus 17, then you can have 20 neutrons. And for chlorine 35, 35 minus 17, then you have 18 neutrons. So these are the example of isotope, which is, it means atoms of the same element, same number of proton, but different number of neutrons. So far, do you have any question?
Teacher, I have a question.
Yes? Yes.
Isotope is like a sibling, like our sibling. We have the same parents, but we all some different in physical appearance, in some genetic codes. We are different on that. So, can we the isotope is the same like our sibling?
Yes, correct. That's a good analogy, Iliana. You can make analogy isotopes as our sibling. They are from the same parent but different characteristic. But they may have same characteristic, maybe appearance, but different attitude. Okay, can you get it?
Yes, teacher. Thank you.
Okay, thank you to Iliana for sharing. It's such a good analogy, okay? Okay, any more question? Yes, no?
No from me, Miss.
Okay, as we have no question, then we can move to the next part, which is relative atomic mass of isotopes. So for this part, we are going to do some calculation. Okay. So this is the formula of relative atomic mass. The formula is the sum of percentage isotope times mass of isotope divided by 100. So now let's look at the first example. The question asks, chlorine consists of two isotopes, chlorine 35 and chlorine 37. The natural abundance of chlorine 35 is 75% and chlorine-37 is 25%. Calculate the relative atomic mass of chlorine. So we know that the formula of relative atomic mass is the sum percentage isotope times mass of isotope divided by 100. Okay, so to solve this equation, we have to find the percentage isotope chlorine-35 times mass chlorine-35 plus the percentage isotope chlorine-37 times mass chlorine-37 divided by 100. Can I have Francesca? What is the percentage isotope of chlorine-35?
75.
Yes, correct. And how about the mass of chlorine-35?
35.
Yes, correct. How do you know the mass of chlorine-35 is 35?
I don't know.
You don't know?
I just
Actually,
assume
you just assume. Alright.
Sorry,
Does
teacher.
anyone know? It's okay. Anyone know how we want to know the mass of chlorine-35? Because in this question, it does not state that the mass of chlorine-35, right?
Can I try, Miss?
Yeah. Yes.
Okay. I think 35 comes from the total. I mean the sum of number of protons and number of neutrons. So we also call it as the atomic mass.
Yes, correct. We can look for the mass of chlorine-35 on top of this. Can you see this? Just now we have discussed, right? The number on top is the nuclear number, or also we call it as atomic mass. And the number below is the proton number. So from there we can know the mass of chlorine-35, okay? And for the percentage isotope of chlorine-37 is 25, time mass of chlorine-37 is how many, class? The mass of chlorine-37?
37.
Yes, correct. So the sum of this divided by 100, then you get 35.5. So the relative atomic mass of chlorine is 35.5. And bear in mind, student, there is no unit for relative atomic mass. Okay?
Okay, Miss. Noted.
Okay. So far, do you have any question?
No.
Yes?
No,
No?
Miss. No, Miss.
Okay. That's great. Now, I guess we can move to the next part, which is the uses of isotopes. So for your information, isotopes are used in various fields. Let's have a look. So in medicine, cobalt-60 is used in radiotherapy to kill cancer cells without surgery, and it is used for sterilizing surgical tools. And iodine-131 is used for treatment of thyroid disorders. In agriculture, phosphorus-32 is used to study of plant metabolism. In nuclear, uranium-235 is used to generate electricity through nuclear power generator. And not only that, in archaeology, carbon-14 is used for estimation of artifacts or fossil age. Lead-210 is used in determining the age of sand and earth layer up to 80 years. In industry, hydrogen-3 is used as a detector to study sewage and liquid waste. And in engineering, sodium-24 is used in detecting leakage in underground pipes. So many, right? So many to memorize. Do you agree?
Yes,
Yes.
Miss. I
Yes,
already
Miss.
read for my test.
Wow, that's good, Adika. But I don't expect you to memorize all of this. At least, you know or memorize 2 or 3 uses. Okay?
Alright, Miss.
Miss.
Okay, so far, do you have any question? Any
No from
question?
me.
No.
No.
I don't have question, Miss.
Yes, Nora?
I don't have question.
Oh, okay. Sorry, Nora. Okay, now I think we can move to the next part, which is activity time, your favorite time. Okay, for the activity time, I have assigned all of you into 3 groups, and I will assign all of you into breakout rooms later. For group 1, the name is hydrogen 1, the name of isotope, and there is Nora and Francisca. In room 2, there is Atika and Iliana, and your group name is hydrogen 2. And in room 3, there is Fatini and Sabrina, and your group name is hydrogen 3. So what you have to do for this activity time is, first you have to go to files and then click on the lecture task folder. In the folder, you have to download the task according to your group. Is that clear?
Yes. Clear.
Okay.
Crystal clear, Miss.
Okay.
Yes,
Good.
Miss.
Okay. After you have downloaded it, you in the room, in the breakout room, you have to share. You can click on the share button on top, and then you choose Microsoft Whiteboard. And then you can paste the task on the whiteboard for you to do it together, okay? Okay. So for group 1, hydrogen 1, your task is you have to give the meaning of isotope and answer these 2 questions. For group 2, you have to write the formula of relative atomic mass and you have to answer this question and write your working here. And for group 3, you have to fill in this bubble map on the uses of isotope. Okay, after you have done this task, you have to present to your class on the answer. Can you do it?
Okay, Miss.
Yes, Miss.
Okay,
Miss.
good. Yes?
I have a
Uh,
question.
okay, Sabrina first.
Yes. Okay, go Sabrina.
Okay, for my group, do we need to put specific like hydrogen one is to use what? The uses of hydrogen one is what? Or we just we just write in medicine, in agriculture. You can you
You have
understand what?
Yes, I understand your question. So for your task, yes, it is good for you to put the uses. I mean, if you write hydrogen 1, so what is it uses? Okay? You can refer to internet. I allow you to search on internet. Okay?
Okay, Miss.
Okay. Atika Ibrahim, what's your question just now?
I want to ask how how much time do we have to complete the task?
Yes, a good question. I will give all of you within 8 minutes. Is it enough?
Yes, Miss.
Okay. So, that's all for our lecture. Now, I think we can move to the breakout room. I will open the room.
Okay. That's what. Are they isotope? Why? No.
Because they are
They
not.
not because the because the proton numbers of Cl and I is are different, right?
So now we have to continue with this. Yes, because it is the same element which is oxygen, and it has the same proton number kan? Proton number.
Yes.
A different neutron number.
Okay. Now the formula is percentage isotope multiplied by mass of isotope. Why you undo?
Because I got it wrong.
Okay, put the bracket after the
How do we want to erase this symbol?
I also don't know. I'm sorry.
Okay, it's getting harder. It's okay.
Sakini, are you okay?
So far, so good, student?
So far, okay, Miss.
Okay.
Can you go to the next, the orange one? I can have it.
Wait. Miss, this is so hard.
Yes. I found that carbon 14, carbon 12, and carbon 13 has their own uses. So I want to write. It's okay, right, to use the same elements, carbon, or we want to use another elements?
Yes, can.
Okay, Miss.
Just put in whatever you have found, okay?
Okay.
Okay.
Isotope is the element with
Which have
thank you, which has same
number of proton. Okay, we are done.
We have
100
percent times
times 30. Sorry. Times 16. It's
plus
at 0.04 17. 17 plus 0.20. Put the bracket sign.
plus.
Can you put the bracket sign?
Oh yes, thank you.
Multiply by multiply.
Oh, sorry.
It's okay. Multiply by 18.
18. Okay. Wait.
Then divide everything by 100%. By 100, sorry. The line is so straight.
I'm sorry.
It's okay. Okay. Now let's calculate together.
What was the answer?
I got 16.04.
04. Yes, correct. Elena, do we have units?
No,
Why?
because reactor atomic mass doesn't have unit.
Yes.
That's correct, Ilyana. Okay, we wait for group 3 to enter the main room, okay? Okay, nice. Without wasting our time, can we start with the first group, hydrogen 1, to present their answer?
See the picture.
Yes, can.
Yes.
Ah, so yeah, from group one. Okay, so the meaning of isotope. Isotope is the element which has the same number of protons but different numbers of neutrons. Okay, so between carbon and iodine, are there isotopes? Why? Our answer is no, they are not, because the proton number of carbon and iodine are different, and also carbon and iodine is a different element. Okay, so between oxygen 16 and oxygen 18, are there isotopes? Why? Our answer is yes, because it is the same element, which is oxygen, and it has the same proton number but different neutron number. That's all from group 1.
Yes, that's a great job from group 1. All of you can give reaction to group 1. You can give applause or heart. Okay. Okay. For the meaning of isotope, yes, it's correct. But can you present again? Okay, thank you.
Sorry.
It's okay. Okay, for the meaning of isotope, yes, it's correct. But the meaning of isotope based on your textbook is isotope are the atoms of the same element. Okay, so you missed the word of the atoms of the same element. Okay, can you get it?
Okay, Miss.
Okay, for the two question
Okay, Miss.
below.
Okay.
Okay, for the two question below, it is good that you can answer it well. Yes, that your answer is correct. And good job to group 1. You did well.
Miss. Thank you, my group
Okay.
mates.
Yes. Okay. Okay, can we move to group 2, hydrogen 2?
Yes, Miss, can. Give me a second
Okay.
to present my screen.
Yes, sure.
Can all of you see my screen? Oh, I can see
Yes.
Ileana's cursor.
Okay. Can. Now already can.
Okay. The question given to our group, there are two. The first one is to state the relative atomic mass formula. So the formula is the summation of percentage of isotope times the mass of isotope, and we divide it with 100. So that's the first question. The second question is we are given three types of three carbon isotopes with different abundance and different number of neutron. So to calculate the relative atomic mass of the isotopes, we need to multiply the percentage of the first carbon, which is 100 times 16. 16 is the atomic mass of the first carbon, and plus with the second carbon, which have the 0.04% of its abundance, times by 17 of its atomic mass, plus with the third carbons, which have the 0.2% of its abundance, times by 18 of its atomic mass, and then we sum all of it and we divide it with 100. So the answer that we got is 16.04. It does not have any units because we already learned just now that relative atomic mass doesn't have any units. So that's all from us. Thank you.
Great job, Group 2. The formula is correct. But just now you said that you find the relative atomic mass of carbon, is it?
Yes, Miss.
Actually, the question asks for the relative atomic mass of oxygen. But it's okay, but the answer is correct. Okay, you get the correct answer.
I'm sorry, Miss.
And it's okay. And it's good that you know that relative atomic mass has no unit. Okay. Good job.
Okay, right.
Now, can we have group 3, hydrogen 3?
Can you see the photos?
Yes, can.
Okay, this is the uses of isotopes that we found. First is carbon 14, which is used for to estimate the specimen's age. The second one is carbon 12 to replace oxygen. And in the blue circle is iodine 131, which is used for thyroid treatment. Next we have zinc SCE133, which is used for lung imaging. We have cobalt 16, radiation therapy for lung cancer. And lastly is uranium 235, used for nuclear power plants. That's all from us.
Great. Okay, great job, group 3. I can see that there is some isotopes that we didn't cover in syllabus, and that's good. That's a good sharing, a new sharing for your friends. But I would like to emphasize that the circle, the dark orange circle, the dark pink circle, and the dark blue circle is for the fields. Okay, not for the isotopes. Can you understand me? I mean, for maybe you want to talk about the isotopes in medicine. The dark blue should be medicine, the fields. For the light blue is the isotopes and its uses. Okay, that's how you use the bubble map.
Oh, okay, teacher. I understand.
Okay, that's okay. It's a good try. Good job, everyone. Now we can move to my slide again. You can stop sharing. Okay, all of you have done your activity. You can see my slide, right?
Yes,
Yes.
ma'am.
Okay, now let's recap what we have learned today. Okay, first we have looked into the definition of isotopes. Isotopes are atoms of the same element with different number of protons but different number of neutrons. And second, we have looked into the relative atomic mass of isotope, which the formula is the sum percentage isotope times mass of isotope divided by 100. And also lastly, we have looked into the uses of isotopes in medicine, agriculture, nuclear, archaeology, industry, and also engineering. So far, do you have any question? Yes? No? No, that's
miss.
good. Okay. So before we end our class, I would like to share another task for you to do outside the class. So under the files, there is reinforcement task folder. And inside the folder, there is a PDF file named isotope and it uses reinforcement exercise. So inside the PDF, there is some objective questions and also subjective question on isotopes. And also I have attached some YouTube link for you to watch. Okay?
Okay, Miss.
Okay,
Okay,
Miss.
teacher.
Okay. Okay, I think we can end our class here. Thank you for your listening. See you at the next class, everyone.
Thank you, Miss.
Thank you,
Bye.
Miss.
Where's Nora?
Uh, she have internet connection, bad internet connection.
Oh yeah. Have you downloaded the task?
Yes, but I don't know.
Did you just shut off your camera?
Sorry, my background. Okay, now I can.
Kencana.
What is Kencana? I have never heard it before.
Alright, Ileana. I thought you were exchange students from Korea.
No, not. I'm from Malaysia, like you. We are so proud to be a Malaysian.
Ileana, are we on recording?
Yes. Hi.
Hello.
How was your discussion?
Good. A bit distraction by
Just
the
when
evil internet connection.
it's okay. As long as we have finished our work, that's
We
okay.
learn new things. We learn new things. We become improve with, with the this. Yeah.
Are you okay, Nora?
I believe I believe sorry. I believe today we are not just learning new knowledge, but we also been exposed with technologies.
Yes.
Yeah.
New
We
thing.
exposed to the.
Yes.
Mm-hmm.
Hmm.
Just now, oh my God, where I am.
Yeah. I'm gonna admit that I have
Sorry,
technology literacy, so it's kind of hard for me too. Mhm.
sorry.